Okay, we are ready for the week 24 test. Now remember, this test is a good way to not only figure out what you need to do differently on the next test, but also if you decide to study for any of the intervention concepts, going back over the test questions is a good idea. So let's jump in. 24-1. Problem number 1, probability. And it says number line because not only are we going to determine what the probability is, but we're going to place it on a number line. Now you'll notice our number line is numbered, when they numbered it from 0 to 1. You might think, wow, that's a pretty narrow number line, from 0 to 1. But the reason they did that was that when we look at probability, the chance of things happening are either 0%, that's the 0, or 100%, which is what 1 is, the number 1. If you have all of something, then you have 100% of it. So there's one item, you have it all 100%. So we're going to place all three of these statements on that number line based on this spinner. So we have a standard spinner. It spins 1 all the way through 8. Here are the questions. And when we answer each of these questions, not only are we going to place it on the number line, but we're going to identify them as an outcome that is likely, probably going to happen, unlikely, which is probably not going to happen, or neither likely nor unlikely, which means, you know what, we really can't say if it's going to happen or not going to happen. Those are the things that fall in the middle. So, letter A, the arrow lands on an odd number. Well, let's look at the odd numbers we have. Numbers 1, 3, 5, 7. These are all odd numbers. That means half of the spinner is made up of odd numbers. Well, if half of the spinner is odd numbers, then the likelihood is neither. You know what? You really can't say, oh, that's probably going to happen or probably not going to happen. It falls in the middle. So A is neither. And you'll notice we place A right over here on our number line, right in the middle at the 50% mark. All right, letter B. The arrow lands on a 7 or an 8. Here's the 8. Here's the 7. You can see that's only 1/4 of the spinner. 2/8, which is 1/4, 25%. That is unlikely to happen. Now, that doesn't mean you should be amazed if it does happen. If you spin a 7 or an 8, you go, ooh, I spun a 7 or an 8. Time to buy a lottery ticket. No, it just means that if you spun 100 times, the likelihood of getting 7s and 8s is much lower than the likelihood of getting not 7s or 8s, of getting 1 through 6. So in that case, it's unlikely. There's a 25% chance, and we place that on the number line at 1 out of 4. That 2 out of 8 equals 1 out of 4, or 25%. So our unlikely at 25%. Let me go back. On the first one I did, the neither, and we placed that right at 50%. All right, the final one. The arrow lands on a number that is less than 8. So we're looking for a number less than 8. Well, that is likely to happen because, as you can see, if I go back and get rid of that shading and instead shade everything that is less than 8, you can see that we are shading just about the entire spinner. In fact, we are shading everything except the 8. So that's likely to happen. And if it's likely to happen, we're going to stick it right there. It's actually 87.5%, falls between 3/4 and 1 whole. All right, so that's number 1. Go back and review it as you need to with your test. Number 2. There's a bag containing 100 marbles, and they're all either green or blue marbles. Matt starts pulling marbles out at random, recording the color, and replacing the marble, and doing it again. So that's important. The idea of replacing the marble, that makes this an independent event. If he pulls a blue out and records it and sticks it back in, there's still the same number of blues he started with. So far, he has pulled a blue marble 15 times and a green marble 10 times. So that's the other important information in this problem. The important things are there are 100 marbles. He pulled blue 15 times. He pulled green 10 times. All right, question A. Based on Matt's results so far, predict how many blue marbles are in the bag. So we know that Matt pulled a total of 25 marbles, the 15 and the 10 put together, 25 marbles total, and 15 of those were blue. That works out to be 3/5 are blue, or 60%. Now we have two ways we can solve this. We can either put it into a proportion and solve. 15 over 25 equals x over 100. We could multiply 25 times x and 15 times 100. Or we could look at the fact that 25 times 4 makes 100. So we could do 15 times 4 to get x. It's going to give us 60. Or we don't have to do both these. Or we could do 100 times 60% as a decimal is 60. In either case, we would predict there are 60 blue marbles in the bag. Now, that's not an absolute. We haven't counted all the blue marbles in the bag, but we're making a prediction based on Matt's sample. Letter B, we're going to do the very same thing, except this time, Matt does this experiment 300 times. How many green marbles would you expect him to pull out? Well, once again, we already know that Matt sampled 25 times. In this case, 10 of those marbles were green. That's 2/5 or 40%. Now, just as an aside, we could have already known it was 40% because if 60% were blue and all the marbles are either blue or green, then the remaining marbles, the green, have to be the remaining percent to get to 100. So they have to be 40%. What I'm saying is this. I'm saying if you already know that you have 60% and some unknown, when you count all the marbles, you've got 100%, these green marbles, they would have to be what's missing. They would have to be 40%. So then we're going to apply that 40%, and we can either set it up, go back and set it up as a proportion. And in this case, 25 times what makes 300? Well, it's 25 times 12. 10 times 12 is x, or 120. Or we could do 300 times 40% equals 120. Either of those methods will work. This is an or again. You don't have to do them both. Although, you could certainly do them both to check your work. That never hurts. All right, to the back, to the back. Box and whisker plot. Using a box and whisker plot to do some interpretation or to do some analysis. So we've got a box and whisker plot for class 1, 24 students, how much they walked in a month. We have the same thing for class 2. And we're asked 4 questions. Question number 1, there's more variability in the miles walked in class 1 than class 2. Well, that's a false statement. I crossed it off. Here we're supposed to circle every true statement. Because here's what we know. Class 1 walked between 35 miles was the minimum, and the student that walked the most walked 65 miles. In class 2, the student that walked the least walked 20. The student that walked the most walked 70. So we can tell there's more variability in class 2. There's a bigger range. Letter B, 8 students in class 2 walked less than 40 miles last month. Well, here's class 2. Right here. Here we go, class 2. Here's that 40 mark for class 2. And that's half. We know that this median mark in a box and whisker plot, that shows us where the halfway point is. So if there are 24 students in the class, this lower half, this less than 40, actually represents 12 students. So there are 12 students who walked less than 40 miles. Letter C. More students in class 1 walked more than 60 miles last month. Well, here's the 60-mile mark for class 1, and we can see right here that's 25%. Each section of a box and whisker plot from right here to right here represents 25%. And 25% of the 24 students in the class equals 6 students, not more than the group. That means there are 18 students who walked less than the 60, so that's false. And finally, D is true, more variability or a greater range in Class 2 than 1. We discussed that in problem A. Class 2 goes from 20 to 70, whereas Class 1 only goes from 35 to 65. All right, number 4. Mr. Smith conducted a survey in his neighborhood about creating a dog park. He came up with 4 ways to conduct the survey. Circle each method that would produce a representative sample. Letter A, survey every third house in the neighborhood. Yeah, that's going to give us a good sample. Now remember, when you're talking the neighborhood, you're talking the whole neighborhood. You're talking all the streets that make up that neighborhood. That's a pretty darn good sample. Survey every house that has a dog. Well, you know what? You're creating a dog park. What do you think dog people are going to say? Oh, that's a wonderful idea. It would be just like if you were surveying for a skate park and you went only to houses, okay, and maybe you didn't like a skate park idea, but you said you'll survey for it, and you go to only houses that have stickers in the window that say, I hate skaters. Not going to be a good survey. Survey each house on his street. That's a small sample. It's only his street. You run into the risk of people who he's already spoken to about dog parks, and maybe they've shared opinions, and also the small sample problem. You want a bigger sample of people. Finally, survey 5 random houses on each street in the neighborhood. Again, we're back to the whole neighborhood. We're back to lots of streets, lots of houses. That's going to give you a good sample. All right, finishing it out, number 5. We have 3 statements. We're going to match those against a representative sample. They already tell you that they did a representative sample of 40 shoppers. And we're going to match up their statements against their survey results. So statement number 1, 20% of the shoppers shop primarily for groceries. Well, yes, we can see from the table that 8 out of the 40 shop for groceries, and that is 20%. That is a true statement. Statement 2, 3 times as many shoppers primarily shop for household items compared to electronics. Well, here are the household items right here. Household items. 6 people, those are the electronics. Got ahead of myself. So these are the electronic items. 6 people say they shop electronics. Here are the household items. 10 people shop household. If 3 times as many shop for household as electronics, we'd have to be able to multiply electronics by 3 and get household. That is not true. 6 times 3 is not 10. Another way to look at it, divide the household by 3, you don't get 6. So that's a false statement. And then finally, in a group of 250 shoppers at the store, it's expected that 100 of the shoppers primarily shop to buy their clothing. So we know that 16 out of 40 have said they buy clothes there. That is 40%. So if we apply that 40% to the 250, yes, we do get 100. That is a true statement. So what we're saying is this, and I asked you to write this on your paper when we went over the test. 16 out of 40 is equal to 100 out of 250. Okay, so there you go. You have everything you need now to go back over your paper and also to match this up with the intervention topics that you might decide to pursue. Remember, there's always a way to increase what you know, and when you do that, to take a test and improve your grade. All right, if you have any questions, feel free to come see me.